We're going to try our hands down at logarithmic regression. And we're going to go through the same process that we did with the exponential, except we're going to choose, when we get to our regression and analysis equation, we're going to choose logarithmic regression rather than exponential. So let's see what we have here in this information. It says the table shows the U.S. life expectancy according to birth year. Use logarithmic regression to model the data. Then use the function to predict the life expectancy of a person born in 2020, and let X be the number of years after 1900. So we have some data here by birth year beginning in 1950. Now notice it says let X be the number of years after 1990. So rather than using 1950 in my L1 or my X values, I'm just going to go with 50, 60, 70, 80, 90, 95, 100, 105. Now also note that we're going to be making a prediction out to 2020. So eventually I'm going to want to change my Windows setting for my X max to be at least 120. I'll probably put 121. All right, so we're going to take this data, we're going to enter it into our calculator, we're going to find the logarithmic regression, we're going to paste it into our y equals, look at our stat plot, look at our graph, and then we're going to make a prediction. So we're moving over to the calculator. All right, I'm on the calculator, and I've already checked to see if my stat plot was on, and the type of stat plot I want is a scatter plot. I've already chosen that. We've gone through that process before, and you can see here that I've already entered the data, beginning with X values of 50, which represents 1950 or 50 years after 1900. And we entered the data of the life expectancy there into the L2 column. And so let's just go take a peek at first here of our scatter plot. I'm going to hit zoom. 9, zoom stat, and there I'll go. I see I got it. Almost looks linear, doesn't it? All right, now I want to get my regression equation, and we're actually told to use a logarithmic regression, so that's what we're going to pick. So I'm going to hit stat, calc, move my cursor over to calc, and if I look down here at number 9, option 9, I see ln, that's natural log, a natural log regression. So this is going to give me a logarithmic regression. So I'm going to hit the option 9, and we're going to enter through here with L1, L2, and we calculate a logarithmic regression, which would be, I can see that it would be A, 15.09, plus B, 13.38, times the natural log of X. And my correlation coefficient here, my R value is 0.987. That's pretty good. So I'm looking for it to be a pretty close regression. It's going to have a pretty high positive correlation to my data. So I'm going to go into y equals because I want to post or paste that regression equation in there. I'm going to hit vars. I'm going to choose statistics. I'm going to move my cursor over to EQ. We're going to choose the regression equation, and it has posted that regression equation in there for me, and I see that it's definitely going to be a log function because there's the natural log of X. And let's go into our graph and see how this nonlinear function ties to our data. And so it's got a slight curve to it, so it looks like it's running pretty close to my data. And now I want to make my prediction. But first, I need to go to my window, and I need to change that X max out to about, I'm going to change it to 121, because remember, we are predicting out to the year 2020, which is 120 years from 1990. So now I'm going to hit the second, and then to go to the trace button, which it gives me the calc function. I'm going to choose option 1, value, and it's going to take a second to load up. But then I got X equals, and I want to put in 120. This would represent the year 2020, and I hit enter. And my Y value, or in this case, my life expectancy, the prediction would be, let's see if I round it to the nearest tenth, it's 79.15. Let's say 79.2 years. All right, well, there we go. We've used a logarithmic. We've done an exponential. We've done a logarithmic. I think next up we do a logistic. We might need to talk about what a logistic growth function is. Hold on, we're getting there.